Hi guys, this is 9.3 and this section is all about something called residuals, and that's a special kind of graph where what we're talking about, we're trying to figure out if a graph looks linear or not. Even if it has a strong R value, that doesn't necessarily mean that the data is definitely going to end up being linear. There's one more test that you can kind of put data through, and that's called creating a residual plot. Okay, so let's look at, we've got some data here. Whoop, too much. Okay, we have some data here that's about how much braking distance you need based on how fast you're going. Okay. So on the graph, one thing I want to point out is I know that this starts at 30 in your table, but then it counts by tens. You cannot start your graph at 0 and then 30 and then count by tens. Notice they have 10 and 20 here. There's just no data points for that. And we have this data, which looking at it kind of appears linear, but I also see kind of a slight curve to it. So I don't know, I could go either way, whether it's exponential or linear. Okay, so based on the shape of the scatter plot, yeah, we could say it's linear because the points appear to be going in somewhat straight line. And our line of best fit, remember that's the same thing as linear regression equation. You get that off your calculator, is given here. Okay, so you put everything in your L1 and your L2. And then I want to come down here and look at the R value. The R value is 0.98 on there. Okay, so it looks linear right now. But then we have these things called residuals. Okay, and to get this table filled in, we have that equation up above that we put into our y equals. So y equals 5.4x minus 134. And we put in, you know, we did this on the calculator in class. So this shows doing it by hand. We did this in class by putting that into the y equals, then looking at the table and pulling these values right out of the table. Okay? Then, to get residuals, you're taking the the actual data. This is the actual data, 48, and subtracting what the equation predicted, and you get these values. These are called residuals. Basically what they mean is how far away from the line of best fit of the linear regression equation, how far away is the actual data. Sometimes they're positive, sometimes they're negative. They're positive when the actual data is above the prediction, and they're negative when the actual data is lower. Okay? Here's a picture of that, and I'm going to just color code these a little bit better. The red dots are still the same red dots as the scatter plot, but I'm going to color these other dots in blue. The blue dots represent the values that the equation predicted. So this red dot, that's the first one in our table. See how it's higher than the blue dot? That means that a residual will be positive because it's above it. This would be a negative residual down here because it's below the line. And how big the residuals are, you know, you can see, oh, that's further apart, that's a higher value. These are pretty close, they're pretty dead on. Those are going to be lower values. A residual plot is when you graph the x values versus the residuals. So what I mean by that is that you are taking these values here on your x-axis and these values on your y-axis. Let's practice this on the homework. So this is number 2 on the 9.3 homework. Now one thing you don't have to do is find the linear regression equation because it gives that to you. Okay, what you are going to do is open your calculator, and I'm going to clear the memory out of mine. I would recommend you do that. Okay, go to your y equals and type that in, negative 0.4x plus 16.3. Take the time, it's worth it, to set up your table, second table set. This data starts at 2, so put your table start at 2, and it's counting by 2s, and so do your delta table, set your delta table as 2, because then the next part's going to be really easy. You go to your table, and filling in these values is fast. Okay, we've got 15.5. We can just go in order because we've set it up that way. Otherwise, you have to scroll and make sure you only pick the values you need. Okay, so I pulled those out. Those are my predicted values based on the equation. To do my residual is your actual minus your predicted. So 5 minus 15.5 is negative 10.5. 15 minus 14.7 is 0.3. 26 minus 13.9 is 12.1. 23 minus 13.1 is 9.9. 11 minus 12.3 is negative 1.3. Okay, and 3 minus 11.5 is negative 8.5. So like I said, some will be positive, some will be negative. Then you're going to graph these. What you're graphing on the x-axis are these values. So 0, 2, 4, 6, 8, 10, 12, 14, 16. The other axis is your residuals. On this axis. Now, look at your values and find the highest number regardless of whether it's positive or negative, because you got to figure out how to count this axis out. That's 12.1 is my highest, positive or negative. In order to get that high, I'm going to have to count by 3. So it's 0 in the middle, 3, 6, 9, 12, 15. Negative 3, negative 6, negative 9, negative 12, negative 15. And then I'm just going to plot. So 2 and negative 10.5, 4 and 0.3, 6 and 12.1, 8 and 9.9. And I'm annoyed that they don't give you a grid. This is kind of annoying. Alright, there's a dot there. It's inside the circle of the 10. And 12, negative 8.5. Alright. Don't connect these dots. Alright. Now, we're done with the residual plot. What does it mean? You know, what does it tell us? What does the residual plot tell us? Well, that's the next part of this lesson. So if we go back to our book, a residual plot should be random if it's going to indicate linear, which is opposite of what you think. You would think that there should be a pattern to it, okay? But it's when there is no pattern in the residual plot that we say the data is likely to be linearly related. Sometimes, you know, this one's super random, back and forth. This is unusual. I don't see this kind very often, but you see the dots scattered across top and bottom. It's unusual, but it would still indicate linear. Alright, and then these patterns down here that actually look like something. This one is close, 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 further, 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 further. That actually would indicate nonlinear. And a curve would also indicate nonlinear. Now, I can't tell anything beyond that. I can't say, well, that's a inverted U shape. Oh, that's quadratic, or it's exponential. I don't have any way of knowing whether it's quadratic or exponential, but I would know that it's not linear. Okay, that's all I can tell from a curve shape, is that it is not linear. Okay. This is number 9 on the homework, and this kind of helps explain residual plots in a more like visual way, hopefully. If you take your linear regression equation and your data, okay, if I lifted that off of here and brought it over here, and I made my linear regression equation into the x-axis. Let's see how well I lined it up. Oh, not very well. Okay. Then, stop it. If I stretch this out, and it's very distorted, okay? So just kind of picture the center of the diamonds and the data. And let me line that back up a little better. Oh, that's the best one I've done so far today, trying to get it to line up. That's what a residual plot is. It's taking the line of regression and make that the x-axis, and then exaggerating how far each data point is away from that line of regression. And again, when it makes that U shape, that would indicate nonlinear. Okay, so here's the gist of the second part of the assignment, 7 through 9. What you're asked to do is look at 3 pieces of evidence to determine whether your data is linear or nonlinear. The first piece of data you're looking at is the R value. Okay, a strong R value like 0.9746, you know, that would indicate a very strong likelihood of a linear relationship. And if I look at the graph, well, then I start to question things a little bit. Okay, I get a strong R value, but if I really look at the points, they look more curved to me. Why do I still get a strong R value? Because even though there's a slight curve to the data, each data point is still pretty close to the line of regression. So that's why it's making a very high R value. But if I look at this picture, I could say, well, the data could be linear, but I might be starting to question whether it's linear or not, because I do see a slight curve to it. And then the residual plot is the third piece of evidence. Okay, so second piece of evidence, the scatter plot. The residual plot is the third piece of evidence, where I'm seeing, okay, wait a minute, that U shape indicates that something is nonlinear. So what I would write for a sentence is that, oh, I need to be on pen. The data has a strong, and there's many variations of this. I'm just, writing. You have to cite all 3 pieces in your sentences, but basically you have to say it has a strong R value the scatter plot could be linear or nonlinear. Like you could mention that you see a curve. Okay, whatever. But the residual plot indicates the data is probably not linear. How do I come I use the word probably? I use the word probably because, at some point we stopped collecting data. If we continue to collect data, maybe it would, continue to alternate back and forth on either side of the line of regression, and it would change the look of our residual. If I have to make a judgment based on the data we currently have, then I would have to say nonlinear, but I can't guarantee it. Okay, so that is your 9-3 homework. Thank you. Have a good day. See you next time.